Our goal was to build a catapult that was small, simple, but powerful at the same time. There were certain requirements that we had to meet, like it had to have a locking mechanism, its storage footprint had to be 2 feet by 1 foot by 2 feet, and its launch angle and launch distance had to be adjustable because we had to meet a distance of 30 feet and a second distance of 55 feet. And also we couldn't spend more than $125 on the entire catapult.
Okay, so the lever arm is the part of the catapult that applies the torque to the water balloon. So we had to make sure that it would apply the maximum force and torque to the water balloon. So we wanted to make it as long as possible. Now, the lever arm also gets its force from the bungee cord that's pulling on it, which contains all of the elastic potential energy. So we wanted to make the bungee cord as powerful as possible and also adjustable so we could adjust how powerful and how much force it applied. So we wanted to make our catapult adjustable, so we figured the easiest way to do that would be, the most effective way to do that would be to make the launch angle adjustable. Now, the maximum range of a catapult would be at a 45-degree launch angle. And for us to have an adjustable launch angle, we decided the most effective way to do that would be to have both an adjustable stop arm height so that the lever arm would stop at a different angle, and that could be adjustable, and also to have the adjustable height of the catapult itself via the hex screws that are in the base, so that the whole catapult could be shifted by angle. The trajectory of the water balloon follows a parabolic path because its trajectory is subject to the force of gravity. So we use that knowledge to calculate the time that it would stay in the air. And since we know that our projected range is 30 feet, we use that to calculate what amount of force and angle we would need for the catapult to have, and use that in our design of the adjustability of the catapult.
First of all, we chose plywood because it was readily available and it was easy to cut using the machines in the machine shop. As for the bungee cord, why we use that as a source of elastic potential energy, that we felt would deform less easily than any other source such as a spring. And we use steel parts such as nails to put our wood together because we felt that it would hold and deform less easily also. We kept our design pretty simple. It followed a very traditional catapult design. It had a lever arm that was the source of torque in our design. We tried to keep it simple but also innovative, such as the way we use the angle adjustment system. We used hex screws at the bottom of the catapult to raise or lower the catapult accordingly. In the course of 4 weeks, we met as a team and we planned out what we were going to do for the project. And first of all, we did our preliminary sketches. We decided that we wanted the dimensions to, first of all, they had to meet the requirements, but we wanted the lever arm to be as long as possible to give the maximum torque, so that was 2 feet. And after we decided on all the dimensions that we wanted, we modeled each part on SolidWorks and decided that that would be the easiest way to edit our design in the future if we ever needed to in the design process.
Well, as a team, we decided that Elaine and Darsh would be in charge of dimensioning the wood at the wood shop, and then together as a team we would build the catapult together. Our main priority was to make sure that the catapult would fit well perfectly, so precise measurements were taken. We started from the base and built up. We did have some problems drilling holes because it had the largest margin of error, and we had to build a second prototype because our first prototype didn't meet the required dimensions.
The way the catapult works is when the trigger mechanism is released by the rod being pulled out from between the rings, the lever arm pivots around the axle and hits the stop arm. And then after the lever arm stops, the inertia of the water balloon launches it forward, at which point it travels a horizontal distance and hits the target.
Things we found was very important that we did not initially do was maintaining controls. It was very important that the balloon masses were the same to ensure that the catapult would launch consistently, because that would reduce the variable in our testing. And testing was also very important because that was mainly what would reveal our design flaws. And even though during the demonstration our catapult did not launch as well as we had hoped, our team was still very happy that it was a functional catapult.